Welcome to the session 4 of Fluid Mechanics, Unit 3, Dynamics of Fluid Flow. In the last session, that is session 3, we have derived an equation for pitot tube, and this is the problem related to that. So, this is the first problem. I'll read out the problem. Find the velocity of a tube of an oil through pipe when the difference of mercury level in your tube manometer connecting to the two pitot tube is 100 mm. Take CV as 0.98 and specific gravity of oil is 0.8. So here the X value is given, manometer value is given, that is 100 mm. If you convert that to meters, it will be 100 into 10 power minus 3. CV value is given and also the specific gravity of oil is given. So you can determine the H value by using the formula X into SH by SO minus 1. So after calculating this H, you can determine the V actual, which is equal to CV into root of 2GH. CV value is given, root of 2 into G is 9.81 and H is 160 centimeter. You have to convert this to meter. You will get the velocity of pitot tube. So next is second problem. A pitot tube is inserted in a pipe of dia 300 mm. Here, this is a different problem where they have given the static pressure in a pipe is 100 mm of mercury, which is a vacuum pressure. The stagnation pressure at the center of the pipe recorded by the pitot tube is 0.98 Newton per centimeter square. Find the rate of flow of water through pipe if mean velocity of flow is 0.85 times of central velocity. Take CV is equals to 0.98. Say static pressure, since it is given as what is that vacuum pressure, we have to take with a negative sign, and it is 100 mm of mercury. You need to convert that to liquid flowing through the pipe, so which will be equal to 10360 Newton per meter square. You have to multiply the given value by specific gravity of mercury. Stagnation pressure is given, so need to determine the stagnation pressure head value. So that value will be equal to, see here, it is P value divided by rho into G. You will get it as 99.8 Newton per meter square. So mean velocity is given, which is equals to 0.8 times of V actual. CV value is given. So we know Q is equals to area into velocity, and H is equals to, that is differential head will be equal to stagnation pressure head minus static pressure head, which is coming around 2.36 mm of water. And need to calculate what is V actual, which is equals to, sorry, it is not there here, it is CV into root of 2GH. So it is coming around 6.8 meter per second. And after calculating V actual, we can calculate what is mean velocity, which is 0.85 times of V actual. And finally, we can calculate the discharge value, which is coming around 0.408 meter cube per second. Next is momentum equation. Momentum principle states that net force acting on fluid mass is equal to the change in momentum of flow per unit time in that direction. The force F is equal to mass into acceleration, which is given by Newton's second law of motion. And here we can replace this acceleration as dv by dt, rate of change of velocity. So the Fv is equal to m into dv by dt. If you take this m inside, so you'll get it as F is equals to d into m into v by dt, where since m is constant, so momentum equation is force into dt, that is F into dt is equals to d of m into v, which is the impulse momentum equation. This F is equals to d of m into v by dt is the momentum equation. F into dt is equals to d into m into v is the impulse momentum equation. So impulse momentum equation states that the force acting on the fluid of mass m in a short interval of time dt is equal to the change in momentum, okay, where d of m into v in the direction of force. Next, let us derive an equation for some force exerting by a flowing fluid in a bent pipe. So for this, a impulse momentum equation is used. Okay. So let us consider this is the pipe bend and consider two sections before the bend and after the bend. So P1, A1, V1 are the corresponding values of pressure, area and velocity at section 1. Similarly, P2, A2, V2 are the corresponding values at the section 2. So Fx and Fy be the component forces exerting by the flowing fluid on the bend in x and y direction. Similarly, the force exerted by the bend on the fluid in the direction of x and y will be same thing, Fx and Fy, but it is in the opposite direction. Hence, we are using the negative sign here. The other external forces acting on the fluid area are, that is here you can see it is P1 A1, that is at section 1, P2 A2 at the section 2. The momentum equation in any x direction will be equal to the rate of change of momentum in the x direction. So this is the formula. Let us take all the force acting in the x direction. So we'll get it as P1A1 minus P2A2 cos theta minus Fx will be equal to mass by second. See here, this dt mass by dt have taken it as mass per second. D of V is nothing but change in velocity. Again, this mass per second, we can replace it as rho into Q because both have the same unit. It is kg per second. Into change in velocity is V2 cos theta minus V1. So, you'll get the value of Fx. Similarly, if you take the Fy forces, we will get the F force exerting in the y direction. So this is the equation. So resultant force can be calculated, which is acting on the bend will be equal to Fx square plus Fy square, and angle theta will be equal to Fy by Fx. So let us solve one problem on pipe bend. So this is the problem. A 45 reducing bend is connected in a pipeline, the dia at the inlet and outlet of the bend being 600 mm and 300 mm. Here, it is not a uniform pipe. You can see at the inlet or at the starting, at the section 1, the dia will be more. As we go, that the section 2, the dia decreases. Find the force exerted by the water on the bend if the intensity of pressure at inlet to the bend is 8.829 Newton per centimeter square and rate of flow of water is 600 liters per second. Okay. So here D1, D2 value is given, P1 value is given, Q. It is given in liter per second. You need to convert it into meters cube per second. And area 2 you can calculate. You need to determine the Fx and Fy value. Here velocity value is calculated by using the continuity equation, that is Q divided by A1. It is coming around 2.123 meter per second. Similarly calculate V2. So it is coming around 8.492 meter per second. Now applying the Bernoulli's equation at section 1 and 2, you will get the value of P2 which is not given. Okay. After calculating this V1, V2 and P2, now use the formula directly, that is Fx and Fy formula, get the answer. So Fx is coming around 19.68 kilonewton and Fy as minus 6.31 kilonewton. So we can calculate what is the value of resultant force, that is Fr, which is coming around 20.6 Newton. Thank you.